Assalamualaikum and hi everyone. My name is Irene Shafira binti Muhammad Fakorazi, and today we will be presenting our project on modeling unemployment trend, where we find the best quadratic curve, error vector and magnitude of error by using maple and manual calculation. Each of us will cover different aspects of the topic to give a complete understanding. Unemployment is one of the major measures of a country's economic health, showing the ability of a community to provide employment for its citizens. Unemployment individuals are those who are capable of working but unable to find a job. This data is produced by the Labour Force Survey (LFS) that feature on OpenDosem, the official open data portal of the Department of Statistics Malaysia. This analysis focuses on the monthly unemployment people in Malaysia from January to October 2024.
Hi, my name is Nadia and I will explain manual calculation for least square method. Okay, to find the least square solution, we use quadratic model and the equation we use for our data is y equal to a plus bx plus cx squared. Okay, to obtain the best fit curve using least square method, we use normal system. Okay, for normal system, we use formula A transpose AX equal to A transpose B. First, we compute A transpose A and A transpose B, and we can see the answer here. Okay, next, for manual calculation, we use quotient elimination to reduce to row echelon form to find the best fit curve. And we find the best fit quadratic curve is y equal to 551.4 plus 5.2758x minus 0.5303x squared.
Hi, my name is Aina, and now let's look at the manual calculation for the error vectors. Okay, this is our crucial step in validating how well our quadratic model fits the actual unemployment data. As shown in this slide, we use the E equal to B minus AX, where B represents the actual unemployment figures, and A is the matrix that include time values and their squares to match our quadratic model. And X is the vector of coefficient from our best fit equation. And the best fit equation is y equal to 551.4 plus 5.2758x minus 0.5303x squared. Firstly, we compute our AX, which gives the predicted unemployment value for each month. This result is shown in the middle column of this slide. And then, by subtracting the predicted values from the actual data B, we get the error vector, which display in the last column. So, each value in the error vector shows the difference between the actual and the predicted unemployment for a specific month. These small differences suggest that our model captures the general trend quite well.
Alright, so on this slide I will explain how we manually calculate the magnitude of the error vector. We use this formula magnitude of error vector equal to B minus AX. It basically means we want to find the difference between the actual value B and the predicted values AX. So what we do is take each number from the error vector, square them one by one, and add them all up, and then take the square root of the total. And like here in the calculation, we square values like 3.8545, -2 and -2.8304, and so on. Then add them up, and we get a square root of 63.866. Finally, we take the square root and get the magnitude of the error vector equal to 7.9917. This value shows us the size of the error. The smaller it is, the better our model is at predicting the actual values.
Assalamualaikum, my name is Amira Adriana binti Ahmad Tamizi. I will explain about our quadratic equation graph. First, we have the quadratic curve fit graph. To plot this graph, we use the quadratic equation in the form of y equals to ax squared plus bx plus c. We insert our fitted equation, which is y equals to 2757 over 5 plus 1741 over 330x plus 35 over 66 x squared. And for the x-axis, we use a scale from 0 to 10, and we get the shape of the graph is a parabola that opens downward, also known as concave down. For the second, we have the scatter plot graph. This graph shows the original data points. For the x-axis, represents the dates from 1st January 2024 until 10th January 2024, while the y-axis shows the numbers of unemployed people for each date. Lastly, we have the quadratic fit with data points graph. This graph is a combination of both the scatter plot is from original data points and the best fit curve that we obtain using our fitted equation.
In conclusion, by using the least square method, we were able to find the best fitting quadratic curve. The scatter plot shows there is a negative relationship between date and unemployed people. The magnitude error of 7.9917 is relatively small compared to our unemployed data that range from 551 to 556. This indicates that our quadratic model has a good job fitting the data, even though not perfectly. That's all from our group. Thank you.